Looks like I am recording and the sound is good, and yeah. So today we're going to do another Do It With Me. I'm going to do an example with you, and there are 4 questions that you can do. I really encourage you to pause the video, give it a shot yourself, and yeah, let me know in the comments if you have any questions. So let's get to it. Here's the example. So today is going to be about first principles, which is one of the places where you can almost always get 4 or so marks. So this is worth studying. I do this in a few steps. So my first step is always on a scrap piece of paper, scrap paper. I just figure out what the first derivative is using using differential rules. So this times that would give me 4, and x squared becomes just x, and this becomes just 3. So now I already know what the answer is. That was my first step. My second step, so my next step is to figure out what f of x plus h is equal to, and to simplify it as much as possible. Now, let's just take a moment away from this question and just talk about what does this mean. If I have an equation, f of x equals all of this rubbish, then if they say f of 5, what they want us to do is substitute 5 into all the spaces where x used to be. So what I would get is this squared plus 3 times 5. Wham. Or if they said f of t, everywhere I used to have an x, I now will have a t. So it would be 2t plus squared plus 3t. Okay, I'm telling you this because sometimes in the papers it's useful to know what they mean by this notation. All right, back to f of x plus h. So just as we discussed just now, everywhere there used to be an x, there's now an x plus h plus 3x plus h. Okay, so now you will write out your brackets, double them up, plus, and this one I'm just going to distribute the 3 into the brackets. 3x plus 3h. Okie dokie. Now, you can EBA or whatever you do to get your brackets sorted. And if you need a video on that, let me know in the comments. We have x squared plus 2hx plus h squared plus 3x plus 3h. All right. Distribute the 2 in. I end up with 2x squared plus 4hx plus 2h squared 3x plus 3h. Do I need to simplify? Nope, that's it. My third step is, wrong blue, that blue. My third step is to actually use the formula that we have on the formula sheet. So limit as h tends to 0, you have to write this every step until we substitute in 0. Okay. F of x plus h minus f of x over h, and then we limit h tends to 0. Now I substitute in this business, 2x squared plus 4hx plus 2h squared plus 3x plus 3h minus, and now please use brackets, because if you don't, you're going to make a sign error, or the chances that you make a sign error is huge, and then you lose your marks, and we don't want that, do we? 2x squared plus 3x over h. Our limit as h tends to 0. Yeah. Oh, that line was horrible. I'm gonna try it one more time. Not much better, but let's get on with it. hx plus 2h squared plus 3x plus 3h minus 2x squared. And this is usually the one where the sign error happens if we don't have the brackets, because this times by this gives me negative 3x. And then all of that over h. Okay, so if you did this right, what's going to happen is that every term that does not contain an h will cancel out. If that doesn't happen, something went wrong and you need to go and redo the thing. But here I have 2x squared minus 2x squared, so those two are like dead. And over here I have positive 3x and negative 3x. Yes, that is a plus. I know my handwriting is terrible. It's never gonna get better. It is what it is. All right, my next step is to, let's call this, my fourth step is sub in 0. And this, no, is factorize. That's not a factorize. All right, so let's do that. We have the limit as h tends to 0. I'm going to take out an h from everything. 4x plus 2h plus 3 over h. All right. These two cancel out. Die. And now our fifth step is substitute 0. Okay, let's do that. So we're going to have f prime of x equals, and now because we're subbing in 0, we no longer have to write this limit business. So it's just 4x plus 2 times 0 plus 3. And that gives us our final answer of 4x plus 3. Bam! Woo! We win. So, how about you try one? Let me erase all this. And here we go. We have f of x equals 2x squared minus 1. And by the way, I forgot to mention, every question comes from a past paper. Every question. So pause, give it a shot. Let's see what you got. Okay, on my scrap paper, I figure out what my answer is going to be. It seems that the first derivative of this whole business is just going to be 4x. Easy peasy, lemon squeezy, I hope. I do my fx plus h, 2x plus h squared minus 1, and remember, double up your brackets. I am going to flex a little bit and do it in one step. And yes, you are allowed to skip steps, but you need to do this, you need to practice it before you get to the exam. Because if you skip steps and you keep making small calculation errors, then you lose marks. So then don't skip steps. But if you can skip steps and maybe finish more of the paper, that's also a good thing. So you're going to have to figure out what works for you here. Anyway, moving on, we have 2x squared plus 2hx. No. Plus 4hx plus 2h squared minus 1. Now I use my formula. F prime of x equals the limit as h tends to 0 plus h minus, I'm wondering if you guys have to write the formula every time. Let me just double check that quickly for you. Substitution, it doesn't look like you're getting marks for using the formula, but I'm just kind of suspicious. Just do it. Like, don't give them reasons to deduct marks. 2x squared plus 4hx plus 2h squared minus 1 minus my original formula, 2x minus 1 squared over there, h. Boom. Limit as h tends to 0, 2x squared plus 4hx plus 2h squared minus 1 minus 2x squared plus 1 over h. And again, everything that does not contain an h gets cancelled out. Minus, plus. And next step, we're going to factorize the limit as h tends to 0. And h 4x plus 2h, looks like that's it, over h. Die. And now we can substitute in 0 because we won't have a 0 under the line. So we have 4x plus 2 times 0. So our first derivative equals 4x, which we already know is the answer. So yay, we did it. Okay, next question. All right. So this one is another, I hope by now it's easy. If it's not, you need to tell me that. This one should be another easy one. And then the one after this is a little harder. It's doable, but it's tough. Or maybe I should say it's tough, but it's doable. And then the one after that is unhinged. All right, pause, give it a shot. Let's see what you got. Okay, on my scrap paper, the first derivative is going to be equal to negative 12x. Looks good. Let's do fx plus h. Negative 6x plus h squared. Negative 6 times x squared plus 2hx plus h squared. Brain fart. Anyway, we have negative 6x squared plus, no, negative 12x, negative 12hx minus 6h squared. Those minuses almost threw me off my game. We have our formula. First derivative equals the limit as h tends to 0. Why am I writing a plus? Minus f of x over h, the limit as h tends to 0. So we have negative 6x squared minus 12hx minus 6h squared minus, and this time I'm going to be set a bad example and not do it because it's just one term. So my negative 6x squared is becoming a positive 6x squared over h. All right. Now, if I did this right, everything will cancel out if it doesn't have an h in it. And lo and behold, negative 6x squared, positive 6x squared, dead, gone, bye-bye. My next step is to factorize. Looks like, but just with the h. Like we can factorize a bunch of other stuff. We don't really want to this time. We just have h negative 12x minus 6h over h. They cancel out. Die. And now I'm going to substitute in the 0. So I have negative 12x minus 6 over 0. So my first derivative equals negative 12x. We did it! Woo! All right. Okay. Now, this next one, initially, it looked pretty straightforward. And I was like, oh, it's easy. Wow. Like, wow. Why am I even doing this? Is this too much work? And then I tried to do it and I was like, oh, oh no, this is a lot of writing. F of x equals negative 2x to the 3 plus 3x squared. It's this to the 3 that made it a little nasty. No, not nasty, just like so much work. Okay, so our answer needs to be negative 6x squared plus 6x. Seems doable, right? It is doable. But the road there is long and arduous. So what we end up here with is x plus h to the 3 plus 3x plus h squared. Okay, what you're going to see me do now is do more steps because this to the power of 3 just makes things a little bit harder. So I stopped taking shortcuts because I know I'm prone to making mistakes in this kind of setup. This one, still easy. I'm going to do 2hx plus h squared. Here I'm going to distribute those two brackets, like get that done. And they end up being x squared plus 2hx plus h squared plus, and then this one distributed in 3x squared plus 6hx plus 3h squared. Okay, now lock it in. This is going to be x times that gives me x to the 3. X times that gives me positive 2hx squared. This times that gives me h squared x. This times that gives me hx squared. This times that gives me positive 2h squared plus x. And that one gives me h to the power of 3 plus squared 6hx plus 3h squared. Ugh, what a mess. Let's do this. So over here, I have an h and an x squared, and I go and look for, here's another h and x squared. Just a note, if you end up with 2hx squared, and then somewhere else in your expression, you have x squared h, remember, x squared h is the same as hx squared. Why? Because 2 times 3 times 2 is the same as 2 times 3. Same thing. All right, let's just erase all of that. Okay. Anyway, this and this becomes 3h x squared. This guy and this guy becomes 3h squared x, and that one becomes h cubed. Bam. Okay, long business, but we're still kicking. Nobody died. My wrist might fall off, but you know. X cubed plus 3x squared plus 3h squared x. I didn't multiply those. Okay, 2 times that. Negative 2 times that. Ooh, is minus 6h x squared minus 6h squared x minus 2h cubed 3x squared plus 6hx 3h squared. Oh my goodness. All right, now we substitute that in. tends to 0. X plus h minus f of x, h, and here we go. Oh my goodness, this is going to be a lot of writing. Plus 3h squared minus negative 2x3 plus 3x2 wham h. Okay, so that's a step. I'm gonna skip writing down all the stuff. So because this is taking forever. 3 minus 6 8. Okay, so after all of that, everything that doesn't have an h in it needs to cancel out. So let's see if we can do that. Okay, and we have that one cancels out that one. That is an h and h and h. This one doesn't have an h. Ah, but there's his friend. Dish, dish, bye-bye. I think I want an extra step for myself here because I can feel my brain being slightly frazzled with all this. And so I'm going to make it easy for myself. Plus 3h squared over h. Okay, I'm going to continue the question up here because I don't have any space left. I hope that's not too confusing. All right, so up here we end up with the limit as h tends to 0 over h, and we take out just, oh, not the 6, just the h, negative 6x squared minus 6, there's 2 h's, so 1 remains, minus 2h2 plus 6x plus 3h. Doink. Okay, now I can substitute in 0. No, wait. Die. Almost forgot my favorite part. Negative 6x squared minus 6 times 0 times x minus 2 times 0 squared plus 6x plus 3 times 0. All of these guys are gone, and all we end up with is negative 6x squared plus 6x. Yes! This one feels like an accomplishment. It was wild, but we stuck in there. Okay, so the last one, I have seen it in one past paper. So it's happened before, but it is rare. What I suggest you do, I don't think that green is as readable as we want it to be. All right, let's go. So we have f of x equals 1 over x, and let's do on a scrap paper. So we can't factorize that guy straight away. We will need to, one of my students used to call it flattening the expression. So we have x to the negative 1. So the first derivative becomes negative 1 times that is a negative x, and then we minus 1, which means we become negative 2. Now you can leave it as this, but when you do the first principles, you will actually end up with this guy. So it's good to know that's going to be the answer. Okay, so my f of x plus h is so simple if we compare it to the previous question. It's just that. The shenanigans begin when we substitute it in. So we have the first derivative. What am I doing? of x equals the limit as h tends to 0 fx plus h minus fx over h. And then we're going to limit h, and we have 1 over x plus h minus 1 over x. We don't need to put the brackets in because it's just one term. And if you want to be safe, put the brackets in. Okay, so now what we've got is a fraction in a fraction. And I just want to remind you that way back when you were in grade 6 or 7 or I don't know, 4, who knows, you used to add fractions together that had different denominators. And the way we dealt with that was to say, okay, we're going to find the lowest common multiple. And for these two, it's going to be 6. So it's times 2 times 2. And for this guy, it's times 3 and times 3. What you do below, you have to do on top. As above, so below. Or as below, so above. So what would happen here is you'd end up with 2 over 6 for this guy, plus 3 over 6 for this guy, and that ends up being 5 over 6. All right, so we're going to do exactly the same for this one. What? Okay, but our LCM is not 6 this time. Our LCM is going to be this thing and that thing. So lowest common multiple is x times x plus h. So over here, we're going to times by x, and over here, we're going to times by x plus h, times by x plus h. All right, so the limit as h tends to 0 becomes x over x plus h minus x plus h over x plus h. Bam. Below the line, still h. The limit as h tends to 0. Now we have, why is there a minus there? There shouldn't be, I think it was just a small scrape by accident. Below the line, I end up with x plus h, and over here I have x minus, and remember when something is on a fraction, there are invisible brackets, invisible parentheses protecting it. So we got to put them back in. And now I'm about to blow your mind. I'm going to write divide by h over here. Why? Because it's just going to make our lives a little bit easier. Why can I do that? Because if I had a fraction, let's say we had 5 over 6 earlier, a fraction just means 5 divided by 6. That's what it is. So if we have all of this business over h, it means we're dividing all of this business by h. So I didn't change anything fundamentally speaking, you know. Okay, over here I end up with x minus h. Almost got that wrong. X plus h. And when you divide by a number, you flip it and you multiply it. Like the Afrikaans kids usually, you flip en mal. And if you say it really fast, it sounds like you're swearing. Flippin' mal, bro. Limit as h tends to 0, I end up with negative h over x plus h times 1 over h, and die. And we end up with, oh, I ran out of space. I'm gonna have to erase a little bit over here. So let's go. Now that the h, so we end up with, let's just see what it looks like. H tends to 0. we have negative 1 over, and you can multiply this in or leave it as is. I think it's slightly less work to actually distribute the x into the thing. So I'm going to be lazy and do it that way. I substitute in x, so I have negative 1 over x squared plus 0 times x. In other words, my first derivative is negative 1 over x squared. Woo! We win! I love it!